Welcome to the Pixel Maths Walking Talking Mock. This is the Edexcel style higher paper 2. A bag contains counters which are red, green, or yellow or blue. Here we have the probabilities for each counter shown. We need to identify the probability the counter will be yellow. All probabilities add up here to 1. Adding 0.2 plus 0.3 plus 0.1 is 0.6. 1 subtract 0.6 is equal to 0.4. The probability here for yellow. We're told that the bag contains 200 counters and asked to work out the number of red counters. We take the probability of red, 0.2, and multiply by the amount 200 to find the proportion that is red. So we have here 40 red counters. Here are the first 4 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of the sequence. So when we go from 2 to 5, we add 3. We can see here we add 3 each time. This means that the series is related to the 3 times table, 3n. Comparing this to the 3 times table, 3, 6, 9, 12, we can see that we don't want 3, we want 2. We don't want 6, we want 5. 9, we want 8, and 12, we want 11. So we must subtract 1. So our nth term is 3n minus 1. Here we have the ages and years of 15 teachers. We need to put this information into an ordered stem and leaf diagram. First off, let's look at the youngest age. We have here 23 and the oldest here 53. So we're going to have our first row to represent the 20s, then 30s, 40s and 50s. Putting the numbers in order, our smallest number here, 23, cross off. Our second, 27, here, 7, and third, 28, 8 is here. Now looking at the 30s, we have 31, 34, 35, and 36 here. Moving on to the 40s, we have 41, 42, 44, 45, and another 45, repeat the 5, and then 50, 0, 52, and lastly 53. Here we're prompted with a key box, picking any 2 values, 3/4 is equal to 34. We're told that one of these teachers is picked at random and asked what the probability that this teacher is more than 40 years old. So if the teacher is more than 40, it will be here, 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 3, 4, 5, 6, 7, 8. So there are 8 possibilities out of a total of 15. So our probability here that the teacher is more than 40 years old is 8 over 15. So this is a conversion graph that can be used to change between miles and kilometres. First off, we've got to use it to change 12 miles here into kilometres. So again, taking your ruler, here on the x-axis, we're going to 12, going up to the conversion line and across, coming out here with a value of 15 is here, 16, 17, 18, 19 point, or it's close to 20. I'm going to say here 19.8. On the exam, the examiner will accept anything between 19 and So it's less than 20. You've got to be really accurate here. We're then asked to change 10 kilometres. So looking here at the kilometres, we're on here, looking at 10. Same method needs to be used, taking your ruler. At 10 on the y-axis, draw a line across and down to the x here, and comes out here on my graph. It looks exactly on 6. I just popped that in the wrong place. So that is the answer to part A. And here, 10 kilometres is equal to 6 miles. Again, there is a margin within what the examiner will accept between 6 and 6.4. Now we're told that Matthew travelled 100 miles. If we look here on our y-axis, it doesn't go up to 100. So we're going to have to use the information we've already used previously to help us work out how many here. Sorry, we're looking at 100 miles, not kilometres. So if we look across here, we only go up to 20 miles. So let's have a look here at 20, or we could have a look at 10, and we're going to have to multiply to get through to 100 miles. So we take 10 to start with, and draw a line up here on our graph from 10. So 10 is just in here, 1, 2, 3, 4, 5, just make sure exactly the right place, up to the line. It goes right across at 16, I can see. Make sure that's lined up exactly there. So here we have our value for 10 miles. So 10 miles is equal to 16 kilometres. So 100 miles, 10 times that amount, when the times are 16 by 10, gives us our value of 160 kilometres. So if you're asked to convert something that is beyond the scale, you need to find something within the scale and on the graph and then multiply up to be able to find the required amount. Here you can see of 100 miles. In our next question, we're asked using our ruler and compass to construct a bisector of this angle. That means to cut the angle in half. To do this, we're going to need to take our compass here and place our sharp point on B. So looking here at the screen, you need to make sure that the sharp point is in B. Now, you need to extend out not too far, but probably about halfway along our line here. Once you've got that, then you're going to take your ruler and your pencil, and go all the way along. So from here and up here. So you must cut this part of the line, the AB bit and the BC bit. Now you're not allowed now to move. So as you lift off, you cannot change the distance between the pencil and the sharp point. Put the sharp point on this crossing point here and do another arc. Again, without lifting, changing, just lift and put your sharp point here. Now do another arc and lift off. So you're doing 3 arcs and you're not allowed to adjust the distance between your sharp point and your pencil. You then have a crossing point. Taking your ruler, you are going to connect the crossing point here with the vertex here of the angle where B is. And that there is bisecting this angle, cutting the angle into 2 equal sections. Don't rub anything out because these lines and curves here count as you're working out, where it says you must show all of your construction lines. Here we're given some information in our table and asked to plot this information onto the box plot. Here we're given all the values that we need. This is our shortest value, our smallest amount. So here at 4, we do a small line. Our biggest value, here 57, we draw another line here at 57 using a ruler. Then we are going to use our Draw the box part of the middle, which has here the lower quartile at 14. This line needs to be a bit longer because this is where the box is going to be. So here we have one line at 14, one at 26, 1, 2, 3, 4, 5, 6, line down here, and our third line for the box, the upper quartile at 30. Here, connecting here to the box, here, and then connecting out to our highest and lowest value. Making that line a bit neater. Do a straight line here, smaller value line, and here. So here we have our box plot, the shortest time, lower quartile, median, upper quartile, and the longest, the highest value here. Jamie goes on holiday to Florida. We're given an exchange rate here of £1 equal to $1.7. Firstly, he changes £900 into dollars. 900 multiplied by 1.7 gives us $1,530. We're told at the end he has $160 and he wants to change it back to pounds. Exchange rate's the same. So this time we take the dollars and we divide by 1.7. In the reverse, 94.12 pounds. Sometimes it's confusing as to which way you multiply and divide, but have a look. You can see here that the numerical value for the dollars is bigger. So check here, the numerical value is bigger. Here, the numerical values, this was the dollar, is bigger than our value here for our pound. The numerical value, they're the same exchange rate, but looking at the number will help us work out whether we've done it the correct way of multiplying or dividing. We need to use our calculator to work out the following calculation. We can simply put the top calculation in brackets, press divide, and put the bottom calculation in brackets. That will get us straight to the answer. Alternatively, you might want to work out the top separately. You get 15.56, and then the bottom calculation, put that into your calculator, writing down all the digits on your display, 2.429, 270474. Then rounding that to one significant figure. Look at the first value that's not 0, 2, straight line, this number, small number, so 2 stays the same. To one significant figure, the answer is 2. This diagram is about bearings. We're first asked to measure the bearing of B from A. Really key part here, from A. That means we're starting at A. From A, north line, clockwise, around to this point here. So taking your protractor, sharp point, the point right here in the middle on A, turning round your compass to line your 0 with your north line. So 2 points here, right in the middle, this north line matched up here with 0. Now going around the edge here, 0, 10, 20, 30, 40, 50, just on there, just before 60, coming out here at 59 on my diagram. So I'm going to use that in a moment. So the bearing here is 59. However, we must quote our bearing as 3 digits. So 0, 5, 9, 0. Really important that 0 there in the front. You are not going to get the mark otherwise. If you check on the exam paper for that one, the examiner will accept any answer between 0, 5, 7 and 0, 6, 2. So just make sure that your bearing that you measured is somewhere between 0, 5, 7 and 0, 6, 2. We're then told that another mass C is on a different bearing, 160, from B. That means we're starting now at B. So we're going to mark up here, sharp point here, the centre point here in the middle, north line marked with 0, going all the way around in clockwise direction to 160. make a little mark, take it away, and we're told here that this is 4 centimetres from B. So using your ruler, putting your 0 on B, turning your ruler around, take this, oh, that's my scale changing, turn this, there, oh, other way. I need to line that up again. Right, let me turn it here. Oh, that's now moving. Turn it up here. There we go. Okay, so I'm going to line this up with my marking, but I'm only going to go to 4 centimetres. Again, here I'm in millimetres, so the point is here. Mark, come away. And I've got to mark this point with an X. So here is point C, bearing 160, 4 centimetres away from B. So 2 parts there to that last part of this question. We're told that a plane flies at 1,400 kilometres in 2 hours and 20 minutes and asked to calculate the average speed in kilometres per hour. So using our distance, speed equals distance divided by time triangle, speed, distance, time. We know that the distance is 1400 kilometres and our time here is 2 hours and 20 minutes. Note we need our answer in hours. Okay, so there are a number of ways we want to do this. We might want to convert it all to hours. Here we've got our kilometres. There are a number of ways you need to be able to find here the speed. So we could change this first to minutes, 140 minutes, 260s plus 20. And we could do our distance divided by our time in minutes, and then times by 60 to convert back to hours, which gives us 600 kilometres per hour. You might want to look at it proportionally as well. So we can see here that we can do this amount in 140 minutes. How much can we do in 10 minutes? Okay, and the numbers work out nicely here. We can divide through by 14, divide through here by 14, and we've got 100 kilometres in 10 minutes. We're interested in the speed per hour, so we're looking at 60 minutes. So from 10 minutes to 60 times by 6, again here 100 times 6, brings us back to the same answer of 600, doing per 60 minutes per hour. Our final speed value here is 600 kilometres per hour. Here we have a diagram of Jim's garden. He wants to cover this with some grass, and we've got the seed, which covers 20 metres squared. We've got the cost. We want to know how much it's going to be for Jim to cover his garden here with grass seed. Now, we've got a trapezium shown here, and we can work out the area of a trapezium by using the formula. Our 2 sides here are parallel sides, A and B. We need to add them together. We need to multiply by the height, so we times by 9, and then we need to times by a half. This is for a trapezium. Or we could split the shape into a rectangle here, A, and then B here. So using our formula here for our area of our trapezium, multiplying through, we have 135 metres squared. So first off, we found the area of the trapezium, or, as I said, split the shape into a rectangle and a triangle. Either way, we have our total. We now need to know how many bags. If they're sold, each bag to cover 20 metres. So 135 divided by 20 gives us 6.75 bags. Can't buy 6.75, so we're going to have to buy 7 bags. Then we need to find the cost. £4.99 each bag times by 7 bags using your calculator, £34.93. Here we have the population in 2003 in Great Britain and India, expressed as standard form. We're going to work out the difference between the population. We've got a calculator, so we can type into our calculator 9.9 times 10 to the power 8. You want to be using the EXP button or the x to the power 10 to the power x button on your calculator. You might press shift, it's normally down near the equal sign. So we've got this, subtract 6 times 10 to the power 7. Giving your answer here in standard form should come straight out on your calculator as 10.3 times 10 to the power 8. We then had the population of Great Britain earlier in 1933, and we're asked to calculate the percentage increase from 1933 to 2003. To be able to calculate the percentage increase, we're going to have to look at the difference divided by the original. That was what it was in 1933, and then times by 100. We're looking at the percentage. So first off, let's working out the difference. We've got 6 times 10 to the 7, subtract 4.5 times 10 to the 7, divided by the original amount, 45 times 10 to the 7, times by 100. This will come out as a percentage, 33.3%. So here on the top, the numerator, we have the difference divided by the original back in 1933 times by 100 to get the percentage. This question, we're given an equation x cubed minus 5x equals 60. We're told that the solution is somewhere between 4 and 5, and we're going to find the solution. So here we are going to use trial and improvement. We make a little table to show all of our working out. Firstly, we take our value for x, and we start with somewhere between 4 and 5. 4.5 would be a suitable starting point. Substituting that here, x to the power 3 minus 5x, using your calculator, you'll get a value of 68.625. We then compare this to the answer here of 60. And we can say that this, 68, is too high. So we must bring down our x. Let's try 4.4. Putting that into your calculator, we come out with 63.184. Again, too high. Try again, 4.3, and we have 58.007. This is lower than the 60, so here we have low. When we have this situation next to each other, consecutive, 4.4, 4.3, one being too high, one being too low, we know that one of these is going to be the answer. So first we must check 4.35, halfway between these two values. Substituting in 60.56 to 875. Higher than the 60, this is too high, therefore the answer for x, correct one decimal place, is 4.3. Now this question is about Pythagoras. We need to work out the length AC. This is our right angle, draw an arrow across. We're finding the hypotenuse, so we will be adding. We take 7 squared, 8 squared. 7 squared is 49, 8 squared is 64. Add 113. Square root 113. We get 10.6301, 4581. 2 decimal places, decimal point, count 2, 1, 2, draw a line. This number, small number. This number stays the same. Final answer, 10.63. In this question, we've got to do some problem solving. We've shown here two options around having a water meter and not having a water meter. We're told this person, Henry, uses 180 litres each day and he wants to pay as little as possible. So we've got to work out, is it cheaper for him to have a water meter or no water meter? So let's call this option A and this option B. So let's look at option A. For option A, we've got a charge of £28.20 per year. He's got to pay that. Then there is a charge for every cubic metre of water used, and we're told that he's using on average 180 litres a day. So we're going to change this first off into cubic metres. So 180 divided by 1,000 is going to give us how many cubic metres? So we've got 0.18. These are how many cubic metres is used each day. Now, the charge for each one of them here, changing that into pounds. We've got pounds here, so we change this to pounds as well. So 0.9122. Keep the 2 2s to keep it accurate. And then for each day of the year, so we've got 365 days. So our costing for A is going to be 365 days times the cubic metres per day times the cost per cubic metre in pounds is going to give us our value of £59.93. But we must also add the £28.20 to give us our total price of £88.13 with a water meter compared to the flat charge of £107 per year without a water meter. So what is cheaper? The water meter, having a water meter is better value as this amount here is less than the charge of £107. This table gives information about the times and minutes that 106 shoppers, the total here, 106, spent in a supermarket. We can see that our groups here, we have group data between 0 and 10, 10 to 20, etc. The median is the middle value. So if we have 106 altogether, the middle one, the halfway, will be the 53rd value. How can we find the 53rd value? Well, our first group goes up to 20. Our next group goes up to 37. 20 plus 17 makes 37. Still not high enough. 37 plus 12 is equal to 49. Still not high enough. Our next group, however, goes up to 81. So this group's too low. This group contains the median, so the 30 to 40 group. We're then asked to estimate the mean. Give our answer correct to 3 significant figures. We don't know this, we're going to have to take the midpoint. So looking halfway between 0 and 10, we have 5, 15, 25, 35 and 45. Multiplying each of our midpoints with our frequency, the column is here ready for us, we have 100, 255, 300, 1120 and 1125. Adding up our total here, we have 2,900. So our mean now is our total of our midpoint times our frequency divided by our total number of shoppers, 106. Putting that into a calculator, you're going to get a decimal, 27.35849,059. 3 significant figures counting 1, 2, 3. Draw your line. This number's a big number. Number in front grows up. 27.4 is an estimate of the mean for this grouped frequency data. On July the 1st, 2004, Jack invested £2,000 at 5% per annum compound interest We need to work out the value of Jack's investment 2 years later. The number of years, 2, 2004 to 2006. It's a percentage increase. So actually we've got 100% plus our 5%, 105%. We want that as a multiplier, so 1.05. Finding our multipliers, we always divide from a percentage to get to a decimal, dividing by 100. So the original amount, 2,000 invested, times by our multiplier, which is an increase, 100 plus 5%, to the power 2. That's the number of years, and it's compounded. So we have our value after 2 years, £2,205. There are 2 sets of traffic lights in Georgia's route to school. We've got the first set here and our second set. We're told that the first set, 0.4, this needs to add up to 1, so our value here must be 0.6. Similarly here, we have 0.3, so this must be 0.7. Branches must add up to 1. This repeats here, 0.3, 0.7. The probability that both sets of lights will be red. To get both sets of lights being red, we're going to go up here and up here. Red, red. So both being red, we're looking at the yellow line there, and we're multiplying through. 0.4 multiplied by 0.3, which gives us our probability of 0.12. When we go along the branches, we're multiplying. We're then asked to work out the probability that exactly one set of the traffic lights will be red. So if one's red, the other one not. Now there's 2 options or ways that this could happen. We could get red to start with and then not red. So that would be our first one. We'll work out the probability of that in a minute. Secondly, we could get not red first, then get the red. That would still be one way of exactly getting red. So let's work out the probability of each one of those. The first one, the green, we have 0.4 times 0.7, which is equal to 0.28. Here, 0.6 for the blue, and then multiplied by 0.3 is 0.18. Add these 2 together, because there's 2 ways of happening. We have our total probability of 0.46. So here, the 2 options going through, total probability 0.46. In a spring, the tension, T newtons, is directly proportional to its extension. What does that mean? T, directly proportional to some constants, x. T, directly proportional to some constant, x. We're going to write this in a formula. So we're going to change this directly to T equals something, is T equals K something, x. We've got some values for our tension, 150 is equal to K times x, the extension, 6. Substituting our values, we can find our answer for K. 150 divided by 6 gives us our numerical value for K as 25. Put that back into here and we have our formula T equals 25x. Now we can use this to calculate the tension if the extension is 15. Then for the tension will be equal to 25 multiplied by 15. Tension is 375. We can also use this in the other way. If they give us the tension, being 600, is equal to 25x. That's the extension. So to find our value for x, 600 divided by 25, so x is equal to 24. The extension there is 24 centimetres. Here we have a right angle triangle, but we have an angle labelled. This means it's not Pythagoras, it's trigonometry. So, ka, toa. Okay, let's label up sides. Number 1, right angle across hypotenuse. Angle across opposite. Leftover side adjacent. Which side doesn't have anything on? H. Cross off H. So here, if you're using SOHCAHTOA to remember which trig ratio, we've just crossed off H. We cannot use this. TOA is the ratio we will be using. Quick sketch, T-O-A. Tan is the angle. We don't know it. X. O is 4.5 and A is 12. To be able to find tan, X, we're going to need to take the opposite and divide by the adjacent. We want to know X. So to find X, finding an angle, we're going to need to use our inverse function. On your calculator, you're going to need to press Shift and then tan. You'll see it above the tan button, tan to the -1. You've got to press Shift. Open your bracket, 4.5 divided by 12, close your bracket. If you put that into your calculator now, you should come out with the answer 20.55604.522. One decimal place, one decimal point go one place. This number's a big number, this one goes up, 20.6. So our angle here in the triangle is 20.6, correct, one decimal place. Here we have an algebraic fraction to solve. Our first step is to multiply through here by our denominators. So we're going to multiply each term by 2x minus 3 and each term by x plus 1. So our first value here on our top, we're going to have this multiplied by here, this multiplied by here, multiplying both on this side together in two brackets. Our first step is this. I have multiplied through by 2x minus 3 and x plus 1. Okay, now let's simplify these terms. Here we have x squared plus x. Here we have 8x minus 12 is equal to double brackets here. So we're going to have some quadratic 2x squared plus 2x minus 3x minus 3. Simplifying this, we can see here, we put these terms together and these terms together. So then we have x squared plus 9x minus 12 equals 2x squared minus x minus 3. Okay, let's put this all on one side. So if we make this 0, we're going to have x squared, take away, minus 10x. Here, we're going to have to add the 12. So we're on minus 3, add 12, gives us positive 9. We now have a quadratic that we can solve by factorising. So here we're going to put this into two brackets. So we're going to have x minus 1 and x minus 9. How do we get this from? The coefficient here is 1 times 9 is 9. Factors of 9, we've got 1 times 9 and 3 times 3. We've got to make minus 10. So to make that, we're going to have to minus the 1 and minus the 9. So both here minus 1 and here minus 9. That equals to 0. Make each bracket equal to 0. If we've got something times 0, one of the brackets got to be equal to 0. So x minus 1 equals 0. X equals 1. X minus 9 equals 0. X equals 9. So our two solutions here for x is x equals 1 and x equals 9. Here in Edexcel, normal prices are reduced by 25%. So they're going down. We've got a decrease. We're starting with 100%, subtracting our 25, we're left with 75%. As a multiplier, divide through by 100, converting your percentage to a decimal, 0.75. So we've got the normal price times by the decreased multiplier, and we're going to get our sale price of £12.75. How do we find the normal? Divide through by 0.75. Rearranging our equation here is going to give our normal price before the sales, which should be more, which comes out at £17. The normal price was £17. Here we have a diagram which shows an equilateral triangle with the sides length 6. We're told that P and Q are the midpoints, so here and here. So half of the 6 are distance here, 3 and 3. Here we are shown a sector, APQ. It's an equilateral triangle, so we know our angle here is 60. We need to calculate the area of the shaded region here, give our answer correct to 3 significant figures. So first off, let's take the area of the sector. So here we have 60 out of 360 times by the area of the circle, pi times radius, 3 squared. Putting that through on our calculator, the area is 4.712. So here we're finding a proportion, 60, the angle here, equilateral triangle, divided by 360 times by the area of the full circle. Now the area of the triangle. For this, we're going to use half AB sine C. So we have an angle in the middle of 60 and our two lengths either side enclosed, which are 6. So half times 6 times 6 times sine 60 gives us the area of a triangle, 15.588. We want to know the area of the shaded part. So the last step, the full triangle, subtract the area of the sector, gives us the area of the shaded area, 10.876. 3 significant figures, 1, 2, 3, draw the line. This number's a big number. Number in front rounds up to 10. Units, centimetres squared. So area there for the shaded part, 10.9 centimetres squared. Our next question is about bounds. We're given a formula here, m equals L multiplied by L to the power 3. Our first value for D is 8, correct to one significant figure. The lower bound, therefore, is 7.5, and the upper bound, 8.5. We have the value here for L, 6.4 to 1 decimal place. Upper, 6.45, lower, 6.35. We're asked to calculate the upper bound of M. Since we're multiplying here to find M, D multiplied by L3, if we want the upper, we need to have the largest possible value for both D and L. So we'll take our upper bound of D, 8.5, and multiply that by 6.45, the upper bound for L to the power 3. Multiplying that through, 2280.857, and then it continues. We need to give our answer correct to 2 significant figures. So first 2 digits, 1, 2, that are not 0. Look at the next number, big number, so the number in front rounds up to 3, and then replace here for 2 zeros. So rounded to 2 significant figures, 2,300. Here we're asked to simplify this algebraic fraction. We need to factorise both the top, the numerator, and the denominator. So take out a common factor of x at the top, and also here x minus 2. Can cancel our x's here, and left with x over x subtract 2. Here we've got an algebraic fraction. We need to multiply our denominator here by our 2, and here our 1. And our common denominator of the 2 valued terms here multiplied together. So we'll have 2 bracket x plus 1 minus 1 bracket 2x minus 1. So we're multiplying here and here, all divided by 2x minus 1 multiplied by x plus 1. So the same rules apply as if these were numbers. 2 over 7, take away 4 over 5. We're multiplying here by 5, here by 5, here by 7, here by 7. So we're just taking our algebraic terms to do the multiplication. Multiplying out those brackets, we've got 2x plus 2 minus 2x plus 2. Sorry, at the end there, not plus 2, minus 1 times minus 1, which is positive, but it's positive 1. So here, minus 1 times minus 1, positive 1. All divided by 2x minus 1, x plus 1. Here we can simplify here. 2x cancels with the minus 2x here. 1 plus 2 gives us 3 all over 2x minus 1, second bracket, x plus 1. For this question, we're asked to find the length AB. Here we have a side, an angle enclosed by the other side. So we can use our cosine rule to be able to find the missing length. We have the situation side, angle, side. The angle is enclosed by two sides here, 5 and 8. So using our cosine rule, we can find a squared is equal to b squared plus c squared minus 2bc cos a. Doesn't matter too much about the way you label up. Here is c, but the cos part will be the angle and a and b will be our two sides. So a squared is equal to 5 squared plus 8 squared minus 2 times 8 times 5 times cos 75. Multiplying all of that out, our value for a will come up onto your calculator, 68.29. Keep all the numbers on your display, square root that value to get your answer for a, which is 8.264. Rounding to 3 significant figures, the final answer for a should be 8.26.